Welcome to the NANOG 64 peering track. So you might have noticed, thanks. So as Tony mentioned in the conference opening, we've done some changes to the way that the peering track is programmed, along with some of the other tracks. The content in most of the tracks is now programmed by the program committee. This gives us a lot more consistent program, and it also allows us to broadcast or webcast the presentations. We archive the presentations, and they have the same quality in terms of the content and the logo placing and things like that that the rest of the general session content has. So this is our first time doing this. We really would appreciate your feedback in regards to especially the peering track and then the peering personals that we had on Monday. There's two great ways to do that. Number one is to find someone with the program committee badge, so we all have these white labels that say committee, so come and talk to us. The second way to do that is to fill out the surveys. So please fill out the surveys, and we would love to hear your feedback on the peering track, the peering personals, and what you thought of the new layout. Obviously, we're not in the circle anymore. We're in the general session conference room. So I know some people appreciated the circle setting more. So please give us feedback. We have a pretty full agenda, so I'd like to introduce the first speaker. Daniel Kopp from DKIX is going to talk to us about black holing at IXPs.
Thank you very much. I'm glad to be here and talking about black holing at IXPs. I'm from the research department of DKIX. I'm working there with 4 other guys, mainly to support university projects and also engineering stuff in the company. So I would like to talk about black holing and how we do it. Yeah, how can I go on with the slides? Green button. Green button, okay. Is this the one with the laser or? Oh, all right, I got it. Thank you. Thank you. Okay, this is the things I would talk about. It's how black holing works at DKIX, how you can use black hole if you're a customer, and some statistics that we recently gathered, and some new developments like the research topics that we are at the moment. So first up, how does black holing work? So this is the situation, I mean, everybody knows it already probably, a DDoS attack. So the one thing which is happening here is that like there's coming a lot of traffic against your router and it's getting congested, and like legitimate traffic, like the green arrow, might not get through, it might get dropped. So this is the bad situation, and it might be even worse in IXP environments because you face a lot of high volume ports there that might be different if you have just one peering session going to the same port bandwidth. So this might be different, and this is where the black holing feature at IXPs can help. So this is the things which are needed or which are implemented at DKIX. You have these ACLs at all the ports at the switches, which can drop traffic by MAC address. So what we do is we have this server in the peering LAN, which has an IP address and a MAC address, and advertises his IP address with his MAC address. And if you want to drop traffic as a customer, you just announce your IP space that you want to drop with the next top IP address of that server. So then the ACL kicks in and your traffic gets dropped. And if you just want to drop traffic from special peers, you can do this with a community string. So yeah, with the usual policy, like you would do it if you only want to announce special to special peers. So it's nothing special to black holing. Yeah. So this is just to show how easy it is to get black holing running at IXPs. So this is the shopping list for IXPs. You just need an IP address of your own peering LAN, so it's not public. And you also have the MAC address, and you need to implement the server to get the app running and that the IP address get advertised. And then you need the ACL filters, which are pretty small, it's one-liner. And you need to configure the route server in a way that he allows that you can announce the black hole IP address as a next hop. Because there's some policy things going on so that you can't just announce the IP address of another router so that traffic might get to a wrong router in the IXP. So yeah, that's what needed, is just a few things, and yeah, there are some IXPs not offering black holing, so it would be quite easy to allow this. And yeah, DKIX is it's not charged or anything. It's free. Everybody can use it, and it's there since 2 years now. Yeah, and I'll show you some statistics about usage later on. Using the black holing for a customer, I already talked about some things. You just have to announce the next hop of the server. There's different ways for different IXPs how you can do it. At DKIX, you announce the next hop of this black hole server. At other IXPs, you use community strings. This differs. And yeah, you can do this with multiple route servers. And yeah, it's not limited in any, the prefix length is not limited, but it depends on how your peers will accept the prefix length. So you can try a 32, it's not limited by the route server. But if it doesn't get through to the other peers, you might use a 20/24, which usually gets through. Yeah, and the usual thing, as I said, policy control, whitelist and blacklist particular peers is always possible also with black holing. I'm going to show you some statistics which are pretty new. So here you can see the number of ASNs at DKIX using the black holing feature. It starts from beginning this year, January, and goes to March. And you can see that we have now 600 customers, and there is 300 in the public peering. So here you can see it's like 20 to 30 customers use the black holing feature at the moment. And on the next statistic, you can see the number of announcements of prefixed announced. So this is of course different sizes of prefixes, but it's just the number of prefixes that get announced per day, and it's new per day. So it's only the new prefixes that get announced per day. It starts from December last year and goes to March this year. And you can see it's around between 200 and 400 prefixes get announced for black holing each day. So that's pretty huge. So you see that this, many people are using it and there's demand for it. Yeah. I want to talk about the developments at the moment where our research department is working on. So there's a draft submitted to IETF to standardize how you trigger the black hole. As I said, we use the next hop IP address at the moment, and other IXPs do it different. So we try to get a standard there, and my supervisor just submitted a draft last week ago or 2 weeks ago, I think. And I put the name in there so you can look it up, and you can, if you might to add something to it, or it would be highly appreciated. And I think what is written in the draft is that they are going for the community string, which are other IXPs already using, and they're trying to get the standardized numbers and everything going. So next thing we are doing research at the moment, this is something where I am heavily involved into, is to get insight into the state change, because the problem is that if you drop your traffic in the black hole, you don't see the traffic anymore, so you don't know when the DDoS attack will stop. And what customers are doing is they enable and disable the black holing all the time, so you see a lot of announcements going on. And and we want to have some automation that we can notify the customer the DDoS attack is gone, and they can safely disable the black holing. So it's also it's also funded by the Ministry of Education and Science in Germany, and we just started this, and we will see what turns out and what we can do. So last topic we are working on is to expand how to use black holing. I think it was already discussed at RIPE 68, and the idea is to have more fine-grained control on the black hole that you can also drop based on source or destination IP address, MAC address, or even ports. So, but we already talked to our vendors of the switch, and it seems that it's not scaling enough, so that's where it got stuck, and we don't see the huge demand from our customers for this feature, and it's always a hot topic if an IXP should, go into UDP stuff and all these things. So, this discussion is kind of stuck, and we will, continue if there's more demand of customers asking us. So, So, this was everything from my talk. Thank you very much. So if you have more interest about statistics, a colleague of mine just submitted a paper to a conference. It's called Black Holing at IXPs on the effectiveness of DDoS mitigation in the wild. So it's not public yet, but if it comes out and you're interested, this is the statistics where they came from that I had. And also you can go on our website and go to products, black holing. There's more information on how this works. So thanks again. Yeah, was glad to be here.
Thank you, Daniel. Any questions for Daniel? Okay, great. Thanks. So I'd like to invite Raul up. He's going to talk to us about a work in progress on rethinking the pricing models.
Hello, everybody. My name is Raúl Sellas. I work for Telefónica as peering coordinator. So first thing, some initial statements. This is not any position or any official anything from Telefónica. It's just some reflections of some humble and simple peering coordinator that started working with internet in the early 90s. And what I try to show here is not any, again, official statements, nor even statements, just to present these thoughts and present some open questions. As a matter of fact, I will try to leave some minutes for any question. Okay, so it's the green button, I think. Okay, so first of all, the problem that I like to present here. If you think about it, internet was born in a voice world. I remember those times working for Telefónica, and what we saw is that we were dedicating really expensive circuits and network resources used for other much more profitable services like long-distance phone calls to a new service that it was going to be the future, but it was not so profitable as the voice itself. So we really had there a cost of opportunity when we reserved these circuits for this new thing called internet. So how could we charge that? How the industry start charging this new service? It was not depending on the value that the service offered to the customer. It was not even based on the amount of traffic that was going to be delivered, but rather than that was based on the amount of network resources that you were dedicating to this other less profitable service, which is what we all know, the percentile 95. The percentile 95 is not other thing that the amount of circuits or capacity that I dedicate to a service, to an IP connection, regardless of the other is using it or not. That's the 95. So after these so many years, we still use the same parameter. No matter costs have dropped dramatically, and there is no other service more profitable competing with IP service for the use of the network. So what could we say it's wrong with the percentile 95? What I've tried to present here is two different values, the net margin per megs, how it has evolved along the years, and the cost of opportunity that I was mentioning before, in the sense that if you sell a service less profitable than other that you could be selling, then you are losing money. That's the cost of opportunity. So I differentiate three different areas in this graphic. You can see, for instance, the first area at the top left in the graphic, in which there was not any incentive for the carrier to sell transit because you were taking much more profitable resources to deliver another less profitable service. There was not really incentive. But then after we reached a second area in the graphic where the cost of opportunity became zero as the price erosion in those services went through. Once you haven't got any cost of opportunity, and if you see the blue arrow, which is the net margin per megabits per second, still is quite high, then you really have that incentive. But we are now approaching to the third area in the graphic in which this net margin per megabits per second is really close to zero sometimes, depending on the conditions, the scale of the business, everything. So what we see at the other side of this dotted line in the third area in the graphic is that what we have now is kind of a regulation push in the sense that it's the regulator who needs to assure that the information society, the information services have to go through and they have to rule to promote this. And secondly, there are, of course, new techniques to enhance the profitability of these services, like software design networks, network functions virtualization, catch service collocation beside the final user premises. But still we are in kind of the middle of this graphic, in the sense that sometimes it happens that we pervert the model so that sometimes the more resources that you use, the more you can charge to the other party, no matter you are not having any efficient solution for this. That happens when we use the percentile AI5. You say, okay, I give you this amount of network resources, use it or not, you have this price. Okay, so what can we do? Let's say, what I've tried then to present here is to try to think about the whole problem from the very beginning and try to compare our business with other businesses in other activities in the society. If you think about it, the normal thing is that when someone sells a product, it comes from some raw material, goes to the factory, and then you have the final product to be sold, and then the waste. Nobody wants the waste. Everybody wants just the final product. So maybe we could have some parallelism with this, in the sense that in our industry, what is the raw material? We could say it's the content, the service, the banking transaction, everything that is there, but it needs to be on the other side of the network. What is the factory then? The factory could be the internet. All of us are the internet, all the stakeholders, the software providers, the network providers, the content providers, everybody together makes possible that the product is delivered, which is not other thing than the final service at the final user's home, or the movie or the photo or wherever. That's really the service. Nobody wants the waste, which is the traffic. Nobody wants ones and zeros, I suppose. So if we take this approach, maybe we could start thinking about different models to interact between networks. Okay, so to make a long story short, what can we say at the end of the day? At the end of the day, what we could say is that no matter where this content, this photograph, this service is sitting at the other side of the internet, the service remains the same. We can put the photograph, the service, the cloud service at the other side of the ocean, or just sitting beside the final user. The service is the same, but it doesn't happen the same with the other economical parameters. What we see sometimes is that if I provide more network resources, I'm able to charge more to the other party, no matter that service is more efficient or not. So that's kind of of a problem, I would say sometimes. So, finally, again, I'm not going to state here anything. I'm just throwing reflections and questions. What can we do? There are several possibilities when we try to put a price for a service delivered through internet. One could be the cost-based pricing. That's what we are really using right now. We could use percentile 5, gigabytes delivered. That's what we use, but there are others. Could be the value-based pricing in the sense that I don't measure how much traffic I am delivering or I am accepting or I am exchanging. At the end of the day, what is important is the value that I add. Everybody in this industry adds value to the final user. If some link in the whole chain fails, the final service is not delivered. So everybody delivers a value and needs to be compensated according with that value. Other options, for instance, could be the demand-based pricing. The more demand, the higher the price. That has some problems because the regulator could think that some operators could create artificially scarcity of the network resources so that the prices could go higher. So that's not viable, I would say. And fourth and last model could be a competition-based pricing in the sense that I could say, okay, if AT&T has this price and Verizon has this other, then I am in the middle or I'll be the lowest one. But that again is really difficult regarding regulatory issues and regarding the fact that we are dealing with a commodity. It's really different. It's really between the different providers. Okay, so thank you very much for your attention, and I'm here open for questions.
Well, if you can't talk, I'm just going to talk instead, and I'm going to ask a question. I'm Matt Petak from Yahoo.
We deliberately wanted to give some extra time for questions on this one, so please ask a couple questions.
Yeah, it doesn't look like we're going to be shy. So you had a cool graphic there, Raul, about raw materials in a factory and a good being delivered, and that's a really nice picture. But every time I've dealt with economic transactions, the person who owns the factory goes and they buy the raw materials and pay money for it. And right below that, you had a picture of content and the internet carrying things to the end user. If we take that analogy, does that mean that the internet service providers should go to the content providers and pay them like they would pay raw materials from a factory to make things?
Yes, absolutely. Again, I'm not trying to state here anything. I was just trying to talk about the business model that the whole industry has. Of course, it's not clear who. The key thing for me is who provides more value to the other. So could be the case that the content provider delivers more value to the internet service provider. That could be the case. All of us, together need to find a viable business model so that this business works for everybody. That's the key thing.
I thought it was a great little graphic there, and I just was noticing, wow, if we think about the economics of that puts this in a whole new light. So thank you, Ro.
Thank you to you, Matt.
Hi, Leslie Carr. So I have a bit of a problem with your pricing policy ideas. Cost-based pricing, in fact, would, the last statement refrains technical innovation, because the more efficient, the less cost, therefore the less revenues and profits. I think that's completely incorrect. Because if, let's say, company A makes some technological innovation and company B and C don't have it yet, they can still keep their price the same and make a higher margin in revenue. In fact, cost-based pricing forces technical innovation, because if you want to have higher revenue or even keep up with the competition, you must keep up with the technology.
Exactly, yeah. I'll tell you one example. Imagine just one iPhone and some other brand. The iPhone is not more expensive because it costs more to produce one iPhone. Maybe it's the contrary. They are quite cheap to produce because they produce by the millions. But still, they are the most expensive product in the market. And that's not price valued on cost, and it promotes the innovation and the technology and the investigation.
That's a really simplified model, though, because the iPhone has many more characteristics than transit, which really only has, what is the transit's connectivity level. It'd be more like AT&T, T-Mobile.
Mm-hmm. Yeah, but again, another example with AT&T and T-Mobile or wherever. Imagine the following situation. I could, as transit provider, forget about content providers. Let's talk about just a couple of networks, network A, network B. If one network is selling transit to the other, the provider could say to the other, okay, this is the transit service I'm charging you because I'm delivering, I don't know how many 10G ports through the Atlantic, blah, blah, and this is the final price. Or maybe the other option would be, okay, I will have your catch service inside my network and deliver your service to my final users. And maybe I haven't not that many reasons to charge the same amount of money as the prior model. That's what I'm trying to show. That sometimes the more or the higher the cost, the more able you are to charge higher the bill. But I don't know if I'm explaining myself. That's my only point.
Hi, Patrick Gilmore, Markley Cloud Services. So just to sum up your presentation, let me see if I got this straight. Transit costs less, and therefore my profit's going down, so I have to do something because I like to make money, because really that's what I got out of it. The reality of the situation is, though, anywhere there is a market-based and actual competition-based, where there's more than one provider, which, by the way, pretty much eliminates anywhere Telefónica operates. But if there is a market-based reality, people are making tons of money and prices go way down, traffic rates go way up, everyone is happier. So you'd spend a lot of time explaining, see how hard this is and there's lots of resources and we need to figure out how to pay me more. Because that was the entire presentation.
I didn't say that. I can tell you my salary is the same every month,
okay.
No matter what happens with this industry.
We need to figure out how to pay Telefónica more. But reality of the situation is, like I said, anywhere there's a market, then people find a way to do this and make money at it, and then the consumer is also happier. Perhaps what we need to do, instead of like figuring out where the value chain is or make statements about, well, content's using lots of bandwidth or anything like that, maybe we should just open the market and decouple the physical infrastructure from the services provided upon it, and then we'll see everything get better like it has in every single situation where that has occurred.
Yeah.
We have 20, 30 years of this happening, and every single time we've done that, life has gotten better for everyone except the monopoly.
Mm-hmm. So the question is,
so the question is, are you willing to give that a shot, or are you afraid that if you're not a monopoly, you can't make money at it?
first of all, we would like to be a monopoly, honestly, but we are not anymore in any country in which we operate. There is a competition. Still, it's not really developed competitions in the sense that it's not easy to dig the streets and put new ducts and everything, so step by step. But again, we are not operating in a monopoly. Competition is good for everybody. All of us are final users. I am really interested in having at my house Netflix services, different providers. It's good for everybody. So I could say I fully agree. And again, I'm not trying to state here in this presentation anything. What I'm trying to show here is that there are other means to establish the commercial relations between networks, because at the end of the day, there must be commercial transactions. Otherwise, we wouldn't be receiving our salary every month.
Anywhere there's a market,
Yes.
these things work themselves out, and we don't need to make presentation on it. It just happens.
Yeah, but we are developing this market. Now we have a strong presence from the regulator, and we need that presence from the regulator. But that's now how the market should evolve. We shouldn't need a regulator saying things about the internet. Maybe in the future, we will have pure, transparent competition for everybody, and that I fully agree with you. That's the perfect state that we would really like to reach. Yeah. At the end of the day, I think that it's easy to agree.
Phil Rosenthal from IS Prime. So I agree with a lot of what Patrick brought up, and I also agree the economic model does seem to be broken, but probably from a very different perspective. You know, if you buy the new Apple iPhone, you know, the majority of the profit goes to Apple, and very few people are talking about like, oh, I got it delivered by FedEx. Well, no, I got mine delivered by UPS, so that was a way better service. You know, people care about ultimately the product getting delivered.
Mm-hmm.
And most of us who are operating network and are in delivering, you know, the delivery is really the important part of it. So I think it's an interesting question, you know, while, you know, the whole industry does seem to be asking this question, how do we change things? If you look at any other industry, you know, money flows from, you know, ultimately from the eyeballs, you know, the consumers to the content, you know, the people who are producing things.
Mm-hmm.
And we seem to be talking about changing things more in the opposite direction in this one industry only, and why is that?
I'm not sure to understand you, but yeah, that should be the case. You tell me if I'm answering you or not. That's the point, precisely. In the example that you have put, there is a value chain in the sense that you have the producer of the iPhone, you have the courier sending the iPhone, and at the end of the day, there is money going from the ultimate user receiving the iPhone and the whole value chain. Everybody receives the money. That's my point. With the digital content, should occur the same. One produces the content, other transport it, and everybody should receive a proportional amount of money to the value that gives to the whole transaction. So I'm not sure if I'm answering you.
I think it's more of a question of we seem to be getting to the point where the amount of money going to the transport seems to be increasing relative to the amount of money going to the actual content being produced.
Yeah, I don't know if that's the case. What I can tell you is that the transport services are continuously dropping, as it has to be. So if that's too much or too few money, it's not me, the one that I should say. But I can tell you, it's a fact that if you see how the carriers and the big ISPs evolve in the stock market exchange, it's not big and good times for them. They are suffering because they have a profit and loss account to defend, and that's difficult because prices certainly are going down and costs are going down too. But what is the relative speed of those magnitudes is not clear. So I would say that this industry in every sector is struggling with So yeah, at the end of the day, I haven't got an answer for you. If the revenue or the amount of money that the transport is receiving is fair or not, that's the market who needs to say.
Thank you.
Okay. Last two questions, Christina, Kevin, and then we have to move on.
Okay. Christina Chu with NTT. Actually, I want to respond to Leslie's comment a moment ago about cost-based pricing not necessarily kill innovation. I can give one example, multicast. Multicast is something that, to decide to reduce traffic, but this innovation will not work. Like transit provider have no incentive. Even though, for example, NTT supported it for the longest time, content provider have no incentive to implement it. And, unless the user know to ask for it, otherwise no one care about multicast, because the more traffic for transit providers to move, the more we charge. The more traffic that Akamai push or other content providers push, the more they charge their customers. So in a way, there's certain situations that cost-based actually will kill certain innovation.
Thank you.
Kevin Bloomberg, The Wire. Killing innovation is a great way to talk about regulatory environments in the negative. When the only person that can deliver that package to your house is Brown, then there is no competition and they can charge whatever they want. What the companies have done is charged you based on the value of the packet, not like anybody here has had the net neutrality discussion, which is really what the value of a packet is. Regulation is needed, is still ugly, but is needed when there is no competition or when there is a sway in competition. But it should not be used in a market where competition is healthy. And many markets don't have healthy situations right now, at least. So that's just my regulation sort of thing. But it's hard for our industry to compare ourselves against other industries, whether it be gas, whether it be courier, etc. We have to come up with our own way of looking at what we do and how we can sort of explain it to other people, because it's not the people in this room that are the problem, it's the people outside the room that are the problem.
Mm-hmm. Yeah, fully agree.
Thank you, Raul, and thank you for all the great questions. Next up, we're going to invite Tom Pasico, who's going to talk to us about peering configuration automation.
Hi, I've given this talk several times before, so I'm sorry for those who have seen this already. I just wanted to talk about using netconf and how easy it is to use it for peering automation. So in the old days, a lot of people set up peers and they did it through manual input. This is a very common way. You get on the CLI and you type away. It's very time consuming. You go to a new internet exchange, you're adding 200 peers. It's a lot of time typing stuff in. It's prone to a lot of human error, typos, invalid, inconsistent input, and then the route leaks which happen from that invalid and inconsistent output. It's not a good way to go. People wised up to this and started using templates. So you just copy and paste an IP address and an ASN into your template, copy and paste it into your router. Still lacks any validation and still prone to people not typing it in properly, people not putting it into their routers properly. It's a little bit improved on your time, but it's generally not that great still. A lot of people then have gone out and written expect scripts to do it for them. It's an elegant solution, though it's very tried and tested. It works, but it's not great. You're using screen scraping to get there, so you're having your script log into the router, go and do the work for you. It's slow, it's not great. Security becomes an issue with this as well, because you've got to store a password there somewhere. That password generally will write access to your routers. So where are you storing it? You're storing that in clear, it's not great. And it becomes very time consuming when you have to add exceptions, when you have to change things. It's a lot of code you've got to go through, and it becomes a pain, line after line of expect this, expect that. This is one of the ways that I've seen some root operators doing this, is that pre-configuration. You go to a internet exchange, and you just pre-configure every peer that's there. You do it in an idle state, and when the other side turns it up, hey, it's active. But this is a slow and horrible process as well, because you've got your peers sitting in there in a passive state, save CPU. When they come up, you want to bring them to active, so you need to have another script again to monitor that. Doesn't track what's been set up, what's changed. Doesn't help you with individual settings. Some networks still require MD5s. That's a pain. You need to include that, so that's manual intervention again. Prefix limits change all the time, so it's not something that you can reliably pre-configure. And there's loads of irrelevant information on your device if you're doing this. If you're setting up at a large internet exchange, you've got 500 peers, you've got hundreds of lines of config which is doing nothing, and that'll probably annoy your NOC if you're doing this manually. And quality of data is a big issue. If you have a look at peering DB, it's not good. There's so many bad inputs into there. People put multiple IP addresses. They say, I'm not yet at this exchange as their IP address. You're going to have issues if you're just scraping that. So it becomes an issue in getting it out there. And also without a better way to input, you have human error. So if someone is manually pre-configuring all of this, there's still copy and paste issues likely to happen. It's yuck. So a new recipe of doing this. netconf, it's several RFCs, 4741, 6241, there's a bunch others, there's a few drafts out there as well. Use your programming language of choice, a jump or bastion host, something to do the configuration changes from, and it gets out there. It's pretty simple. So intro to netconf. Originally, everyone thought SNMP, that's the way to go. This is going to do what we want it to do. It failed. How many people here use SNMP set? One. What's your key? It's horribly insecure, and I don't think it really took off in any real way. Using netconf, XML configuration based, so it is machine readable, it is easy to work with, it may be ugly, but it's there. Transactional changes as well, which is really cool. You can load a configuration change, validate it after you've loaded it, and then move it from a stage set into your active configuration or your running configuration. This is an example of a netconf call, just to get the running configuration or your configuration active on a device. As you can see, the call is pretty simple. Get configuration, then the source you're getting it from, running. You can also change that to different methods. Juniper is a good example with this. They've given a lot of documentation as well as handlers for netconf. They've got them on GitHub with a Perl, a PHP, and a Java handler. There's a lot of other examples out there. There's Python handlers, and this is a growing thing. There's more and more getting added to it. So I'm not a coder by any stance. I'm pretty awful at it. But this is a script that I wrote to pull ARP from a router, ARP entries. The call goes into the router and I get the response back like that, which is written there. You can see we get a MAC address, and there's the equivalent information as shown from router CLI. The script opens an SSH connection to the router, sends a netconf request asking for the ARP table. In the case of the libraries included, the Perl libraries, there's the example there on the second line. That's all that's needed inside those libraries to get that information back. In the example, so with the libraries given from Juniper, you can change that call as well. So this one was get ARP table. You can also change it to get route information. You can change it to do a ping. There's all sorts of administrative commands you can do through netconf. But XML is really ugly. As operators, we don't want to look at it all day. It's horrible. But your favorite scripting language can save the day, and this is really easy to do. The scripting languages out there are really easy at handling machine-readable data. So a very basic script can convert ugly XML to a pretty format. Looking at that ARP script, this is a PHP script I wrote to parse that. As you can see, it's about 12 lines of code. That's all it takes to make it a human readable. So when we pipe that through PHP, that's the output that we get from that code. Making it very easy, and you can easily expand this to do whatever you want. You can run through multiple routers and collate the information very easily. Getting XML configuration. So Juniper has some useful commands to see what it looks like. So when you're going through and deciding, hey, I want to program this, I want to make this, in Junos, you can type show configuration pipe display XML. And that'll get you the same output that you would receive through netconf when you made a call to the router. It gives you an idea of what you should look for, how you should get it out. This is an example of a BGP peer configuration as shown through the display XML command. So if you're going to start pushing this out, you can see from the configuration there, sorry if I go back, there's only a few bits of information you really need to look for. The rest is already templated into what you'd be using to set up your peers anyway. So from here, we've got a few variables: IP address, description, prefix count, ASN. That's what you need most of the time to set up a peer. There they are. The rest is all in a template you can store in your scripts to push. So as I just said, the template's very simple. You build out your groups on the router as you would anyway, your peer groups or the Juniper BGP group, and then you just drop these peers inside those groups. There's really only those 4 values you need to insert. If you want, you can also add an MD5 or specific prefix lists easily to any peer in that configuration. Pushing the configuration. The easiest way to do it, again using the Juniper libraries, is to write a config file and then push it. Juniper includes this in online, a script called edit configuration. With this, you can either include in the Junos output or in XML. You drop and paste the file and you just push it to your router. Once it's pushed, this script goes through, does a validation of the input, and then applies it to the running configuration. A different way you can do it is you can write a handler script to do all of this. So this is a script I wrote a fair while ago. You drop in the IP address you want to set up a peer to, AS, max prefix count, the description of it, and where you're pushing it to. That runs out and pushes it out there. Extra things you should think about whilst you're doing this is, should I validate the peer IP ASN details from external sources like PeeringDB, like the IX website, and of course don't troll me for using PHP. A more advanced mode is, like we were saying, pulling this data from PeeringDB once we get past the validation of the data. You can easily just have a tick box and say, I want to peer with these people, pulls that information, their IP address details, their max prefix count, adds that configuration and pushes it to your routers. A front end to do all of this is also a good thing to think about, so it's an easy way to configure it, or any other business function you want to build into this. Validating the setup is also really easy. So this is pulling a reply from the router showing a BGP peer status. In this example, you can see there's the IP address we set up before, 1.1.1.1, the peer ASN 1234, the description, testing session, and the status is there established. So it's really easy to be able to pull this out, validate your sessions, see what you've got happening. So as a summary, it's really easy to build for base automation, even for non-programmers like myself. It's so simple to get into this, and there shouldn't be any reason why you're not doing this. Make the system well, validate it, and it's easy to build on top of. And using the script, even at the intermediate modes, showing the PHP script I wrote, can save minutes of peer session turn-up time, saving days or hours over large turn-ups. Any questions?
I have time for one question, if anyone has any. Okay. Well, this is my 3rd time seeing your presentation. Great job, as
Thank
usual.
you.
Thank you, Tom. I'd like to invite Eliza Cieszynska up from Big Wave IT. She's going to talk to us about standards for peering automation.
Awesome, thank you, Greg. Yep, we're up. Okay, this was a perfect segue to talk about where to get that data from that we then push into our routers. So let me talk about standards for peering automation. Where do we get the data from? You mentioned peering DB, right on. That's exactly kind of the first thing. People put the data in manually, so that's a little bit annoying. It's a little error prone. You never really know if what you're getting is up to date or a little bit delayed or what has happened to it along the way. We're also waiting on an API in version 2.0 to have that data easily, a little bit more easy accessible as it is right now. Right now, there was a way to pull down the MySQL dump, but we have been told at a previous meeting to not use that anymore as this is going to be replaced. And I think there's something coming up after me to talk about the progress on that project. So very curious. Here's a look on peering DB. We all know that, I think. There's IXP websites. I've written numerous parsers to get data out of the IXP websites themselves. Typically, as you join an IXP, they will put you into their database, and that will make it show up on the website automatically, so it kind of feels like the most up-to-date place to get that kind of information from. Unfortunately, it kind of varies by country or varies by site how the situation on that looks like. Some don't have any way to output the data other than parsing through the HTML on their website. Others have some various versions of outputs, comma separated or ASCII or whatever they kind of have around. It really depends on the IXP, and everyone kind of does something different there. There used to be an old PCH comma separated standard that some people adopted, some not. It's just very random back and forth. The third one I could come up with that actually less people know about is the EURIX database. Gris, who's been also working on the peering DB, wrote a bunch of parsers for the IXP websites themselves and puts that data into the EURIX database where it's possible. I did not put the URL in here, that's stupid. But if you dig a little bit on the EURIX website, you can actually find a page that looks like that, and you can issue queries and get semi-up-to-date information with a timestamp when it has been imported. So that's not that bad. Oh, there's the URL, exactly. So this is what we got. It's a little bit all back and forth, and one is input manually, the other one comes semi-automated. What we would like to have is kind of one place where to get that data from, and also writing parsers for all of those sites separately is not the most fun thing to do. So eventually we would really like to exchange data between IXPDB, which is the EURIX database, and PeeringDB itself, to kind of have one source of truth where all of that comes from and have that be as up to date as we can. But on the way to get there, we needed a format to define how that data is exchanged, and that's where that's how we came up with one single portable JSON format that allows for pretty much all the data that your internet exchanges try to encode into their member lists, all the information they have about IP addresses, AS numbers, to put into one place. So there is a JSON schema. It's available on GitHub. We originally proposed this at a RIPE meeting in November, I believe, last year. People liked it real quick, and a couple of exchanges pretty much implemented it on the spot, which was really nice while we were still sitting in the meeting. We got some feedback, came up with a couple of updates. Mostly they were related to add this field or add that field, because that's the kind of information that we keep in our database, and we would like to have that published as well. And then along the way, EURIX adopted it for their import format to feed their database with. Those are all kind of projects that are work in progress and in flight right now, so I'm hoping that soon we'll have something to report on that. A little bit on how it looks like. Basic IXP, so there's the basic information that you would expect from a member list, the IP address, the AS number, anything, how to contact that particular peer, an email address, maybe a phone number, something like that. But in addition, IXPs, we're also kind of looking for a way to get information about their their setup out. So this is the switch, those are the VLANs I have, and then you can link that data together and say, okay, this IP address from that peer participates in that VLAN or has a port on that particular switch. Your mileage may vary on if you want to have that information public about you or not. I know internet exchanges debate that a lot, whether what should be privacy and what should be available publicly on websites. But that's totally up to the implementer to fill in the information in that data format in the end or not. Couple of examples. This is a very basic example, just how it looks like. So there is a version, a timestamp, an IXP list that comes out of the idea that some IXPs run multiple exchanges, but those multiple exchanges are powered out of the same database. So they kind of have the possibility to give you one big schema with all the members and then associate them with the various exchanges they operate, or it could be just one, as it is in this example. And the member list with AS number. I don't know it all by heart right now, but I think the only actually mandatory field to fill in this entire schema is the AS number. So the most basic version of information you would end up with would be a list of AS numbers and that participate. You can even leave out the IP addresses, and that's all. Here's a little bit of a more complex example. If the Internet Exchange wants to publish their contact data, AMSIC's great example here. I think that those guys implemented that already too, so it's available on their website like that. You can add VLANs, you can add your switch information, you can add interface type, speed, but it's all very depending on what you want to publish. So then just to give you an idea how this could be used later on, I literally wrote that like yesterday, like a couple of line script. This is how you get the list of AS numbers out of there and out of a schema like this and get it to print text that will pretty much print lines that you can copy and paste into your router. I put that on GitHub where the schema is this morning, so it's available if someone wants to look at it, and it would literally output a list like this that you can go and paste into your router, just to kind of get an idea what we can do with this, hopefully in the future as this is more adopted and we get one source of truth going on all of this information. Thank you. Any questions? Oh, run!
Hey, my name is Joel. I work for Wikimedia. I love what you've got here, and it strikes me like the next obvious step is a button to push to peer with someone as a request. And you're at a meeting and you have a mobile app. And you're like, yeah, we're going to peer, click, 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 and then you click it into our previous speaker and the session's done before the beer is drunk. So I'd love to be in that world. Thanks.
Cool, thank you. Along with the PeeringDB API, that should be all really useful. Definitely, awesome.
So hi.
Hi.
I'm Patrick.
Hi, I'm Elisa.
If you said this on the presentation, I really apologize, but I might have missed it.
You were not listening.
I so was for some of it. So the IXP database and the PeeringDB and that link and all that stuff, that's all great, but if it wasn't clear, the users are still in control of what shows up in their records. Mm-hmm. So I just want to make sure everybody understands that the IXPs will be able to say things like, you don't really peer here, so you can't just insert bogus data, but they also cannot say you are a member unless you agree to it. The user has to proactively say, I'm a member of this IXP. The IXP doesn't get to list you in the PeeringDB unless you say so, because it's still all user-driven.
Right. This is it from the PeeringDB perspective. I know it a little bit better from the AMSIC's perspective, where I used to work previously, where we had long debates with the members at meetings, what should be put onto the member lists and what shouldn't, due to their privacy concerns. So it was more of a discourse with them.
Hi, Dan Golding. I think there is a little bit of a concern in regard to the fact that EuroIX is a sort of a trade association of European IXPs. And so this is customer data of those IXPs, many of whom are in one way or another in business, nonprofits or otherwise. And so I think there is sort of a valid concern that probably needs to be addressed about the fact that this heretofore, PeeringDB has been a database of peers in multiple senses, and now there's going to be additional involvement from essentially their vendors. And and you may not see an AM6 or DKIX as a vendor, mm-hmm. They're a vendor. So I think that's something that should probably be taken into account.
All right. Noted.
It's Will Hargrave from LonApp. I just wanted to follow up on Dan's point, actually, is that data was already collected for ages by EuroX. So the format and the organization are separate things.
Right. And there's different points to it. I mean, a part of it, the data is already available on the separate exchange websites publicly right now. So it's a matter of pushing it into another database and merging with a different data set. At this point, I really care more about the format in which we exchange that information.
Yeah, and the format's fine, and I don't think anyone is asserting otherwise. This is just an issue of things like data ownership and, the fact that EuroIX is a different sort of participant in this process than has been the case in the past. And, there doesn't really seem to be much of a say, especially, amongst those who are participants in PeeringDB but may not be running PeeringDB.
Absolutely, and how this exchange has to be facilitated needs to be addressed, indeed. Right. Thank you.
Ren, hold on.
Oh, sorry.
Yeah, last question, Ren.
Oh, I'm not looking that way. Sorry, Ren.
No worries. Ren Provo, Apple. Having just joined 30 some odd IXs, we've had a big issue with receiving recycled IP addresses. When a network goes defunct, they don't go and clean up their PeeringDB. I appreciate it if the IX operator, as my vendor, can scrub when a customer departs so that I don't have to spend my cycles as a new customer trying to get it removed.
Exactly. And do they have the means to do this in some manual way and publish that information in a format, or does someone have to go into PeeringDB and scrub it manually and delete those records?
And then I'll stop asking for peering from defunct networks. It's all good.
Just do that. All
Okay.
right. Thank you.
Thank you, Lisa. Next, I'd like to invite Brian Rogan up. He's going to talk to us about how to provide self-service for Google Peers and the portal that they have written.
Hi, I'm Brian Rogan. I'm going to talk, again, a little bit about how we provide self-service to peers at Google. So just start with some quick background. I suspect some of you know a little bit about what Google is. We're in fact one of the largest content providers on the internet. We maintain a global peering footprint. We also offer an embedded caching program for ISPs. To kind of deal with the scale that has come up in the course of growing, we have our own kind of traffic control system that we use in concert with BGP and our caches to balance traffic between everything. And we also expose a user-visible ISP transparency report of network performance that we call the video quality report. So what are some of the biggest challenges that we have peering at Google scale? The single biggest one we have almost by far is just communication. We have a generally open peering policy. We're generally willing to interconnect with anyone subject to traffic level restrictions. But what that means is that we actually have an enormous number of peers, an enormous number of interactions with those peers. And so finding a way to keep all of that straight is actually quite challenging. The other challenge that we have is because we operate this sort of hybrid delivery network where we maintain a backbone network on AS15169 and we deploy caches widely, we actually have it becomes a little bit harder to understand how we're serving your traffic, especially when you combine it with our custom traffic management. And finally, we've struggled a lot as we've grown to figure out how do we have a deeper dialogue with people? How do we have conversations that are more than just about, we need you to augment here, we need you to upgrade there, and how do we actually really get into deep conversations about efficiency and performance on your networks? Again, all subject to the scale consideration that we need to do that with hundreds or thousands of networks. So we came up with an ISP portal. We've come a couple of years ago and presented it, but I wanted to show you some of the progress that we made. So at a high level, our portal provides everything from external documentation through to structured interactions, ticketing and workflow, and also a bunch of data and analysis tools, and now an API. So it's kind of a kitchen sink, but I want to walk through some of the more interesting pieces. In terms of what we're after here, we really have a few high-level goals, and one of the things we really want to have kind of as much interaction as we can in a structured format, right? I mean, I think one of the interesting things of the presentations here has been, all of this manual data exchange is really painful, right? And it's a great way to introduce errors and to slow things down, right? So we tried to get more and more things into kind of automated interactions or structured interactions. We want to give people insight and visibility into how we're sending traffic and how we're going to grow that traffic, so that people can help grow with us and understand what we're doing and scale their networks. And finally, we want to really provide actionable information about what we can do to improve efficiency. And I'll show you a little bit more about what we're thinking there. I think one of the things that we've really been thinking about is actually our goals are really quite aligned with our peers. Low friction for ISPs on routine interactions actually means for us, fewer errors and that we can build more automation, right? Giving people visibility into how we're managing traffic on the network really translates to, informed peers that we can work really well with, where our actions are really aligned. And the same with capacity planning, right? Leads to on-time capacity for us. And us trying to expose performance data that's really hard to get as an ISP helps our mutual users, right? So I'm going to walk through just quickly some of the different functions with an emphasis on getting away from some text in the slides here. Again, I kind of talked about this, but email's quite bad for structured, for scale, right? Copying and pasting things is really the worst possible way to produce an accurate system that grows well. So we've worked a lot on trying to make it so that routine interactions can happen without ever actually doing that. So an example, and I think one that's probably close to everyone's heart, is we are now launching a feature where you can actually turn up a public peering with Google and have it provision while you watch, right? We enter in information that we attempt to validate, and if we can automatically validate information, we'll actually provision PGP right there on the screen for you, and if it fails, we'll actually show you why. Conversely, with our GGC, our embedded caching program, we actually have a structured interaction around how you augment that node where we ship servers, and then also when you're ready to swap it out, we actually have a dialog that walks you through node by node how you can swap it if you need to do an in-place upgrade. In terms of what we provide for visibility, we focused a lot on just how to get across really clear operational status, right? How you can understand how traffic is flowing to you. Again, when you may have you may have multiple different ways of getting traffic from Google, right? Whether it be GGC or direct interconnection or through exchanges or other sources. We've also tried to spend a bunch of time making it so that you can understand our traffic management, right? We actually overflow things and move traffic around in ways that are not exactly intuitive entirely from the BGP perspective, and so we've tried to provide a lot of visibility about what we're doing and why and what we want to do. And finally, one of the features that we're working on releasing soon is a capacity planning tool. So we can actually show you for every asset or interconnection point or peering when we think it's going to need to be upgraded, and soon even notifications giving you lead time so that you know we're going to need to upgrade peering soon. In terms of how do we thought a lot about how we get to kind of deeper conversations. And so for us, the obvious place to start on that is performance, right? So we have inside our peering portal a tool that's aligned with our external video quality report. And so the video quality report shows peers or anyone on the internet, shows you any users on the internet what the performance looks like to your network in different geographies. And so we have in here kind of a full view of that, and then the ability to kind of dive down, prefix by prefix and try to understand what's going on at a very low level in terms of performance in the network. We just launched this week a tool that we're calling traffic flows, and that actually lets you see how traffic is flowing, from what point. And so you can see kind of on the left, we show, fortunately, I had to blur everything out there, so you lose a little bit of context, but you can see everything from the interconnection point, be it an exchange peering or a private peering or indirect traffic. And you can see any GGCs, and you can actually see how much traffic we're sending across each of those paths, and the final column is where the users are. And it actually allows you to understand a little bit about what performance looks like, and where you might have certain paths that we're sending traffic that aren't performing as well as you'd be hoping. And finally, one of the places we're working a lot is investing in trying to get everything to actionable suggestions, right? So it's one thing to expose lots of data in lots of tools and kind of put it there to pick through, and I think that's actually really quite useful for a lot of people, but we're actually trying to do that sorting and that picking for you. And so our work has been all around kind of, actionable suggestions and how can we actually get you to something that you can fix, right? And so right now we implement, we automatically detect anything where we see some of our best practices not being followed. You know, for example, where you have inconsistent prefix announcements, or where you're running out of capacity, or you have traffic overflow. And we're trying to provide specific tools to troubleshoot each of those things. So you can kind of dig in and really make sure everything is well tuned. I think we've had actually some really awesome success stories with this, and we've actually reached out and kind of used these tools as the basis for a lot of ISP conversations, you know, and just a few of them are, you know, things where we've been able to take networks, you know, from 53% HD rated to 95, you know, with no capex, just by actually finding, you know, different misconfigurations or access constraints or you know, issues like that. You know, we detected tons of different BGP misconfigurations, resulting in all kinds of stuff with, you know, leaked prefixes in one place or another, unintended transit overflows. We see a lot of issues with people who have multiple ASNs and having different views of routing leak out that they didn't even know were happening, right? And so again, these are all the kind of things that we're looking to bring to people's attention and to really do it in an actionable way. So you know how to kind of move forward and improve if you so desire. So in the future, we're kind of investing a lot of effort into how we get to action. We spend a lot of time internally thinking about how can we link application level performance with different network issues. And it turns out to be a really fascinating problem. It's not a straightforward thing. How do we say poor video performance is correlated to this problem in a network? It's this link between these two routers that's dropping. And that's sort of where we're trying to go, and we've done everything from you know, different tomography and topology stuff that we're exposing, all the way through to kind of looking at some interesting signals that we get at the transport. And again, we're really trying to get that deep awareness that can get it back to something that's addressable by us, right? And then finally, you know, we're working a lot on how do we understand, like, automatically how to figure out where the best places to deploy or to grow are, so that we know we have a really efficient kind of interconnection arrangement. We're working on even more automation, and again, the goal is to have action happen while you watch, right? Because there's no point of waiting 2 days to find out, like, a peering session didn't come up or something was misconfigured. We're working on APIs because we want to be good partners. We don't really care. If you don't find our UI useful, we want you to have the data so you can do whatever you want with it. And then, you know, getting to alerting so that we can have proactive conversations, and then finally, you know, just really getting to more action. So that was what I had. So that's sort of what I have. If there's any questions, I'm happy to.
Thank you, Brian. Any questions for Brian?
Phil Rosenthal from IS Prime. So I'm actually wondering, and I've asked this question on a similar presentation before at a different forum. There isn't any discussion about the Google bot application, you know, from a content provider's perspective, how we're sending data to you and what's happening inside your network.
Mm-hmm.
And we have actually occasionally run into issues where our customers' content was not getting properly crawled because of a problem happening on Google's network. And you know, it was somewhat difficult for us to actually figure out what was going on. So if there could be some tools for the other side of that also, it would be very useful.
Yeah, that's a really cool idea, actually. I hadn't thought of that. Thank you.
It's Tom Pasika from Cloudflare, and along similar points, in being one of the few networks that's probably outbound heavy towards Google. There's no visibility through the tool of what the traffic is or how it's there, so that would be a very helpful addition.
Yeah, thank you.
All right, thank you very much,
Thank
Brian. You. And lastly, I'd like to invite Aaron Hughes up. He's going to give us an update on the peering DB.
Green button. Hello, I'm Aaron Hughes, CEO of SixConnect and a longtime peering DB volunteer. Here for a peering DB update. So a couple of stats I just figured I'd throw up we don't look at too often, but it's nice to see that peering DB is actually continuing to grow like mad. There are about 7,500 peering networks using peering DB and a boatload of exchanges to go along with that. But along with that, we also have quite a rise in ticket traffic, so supporting peering DB itself has become an interesting workload, most of which will go at least be reduced when we launch the next version of PeeringDB. We're also seeing a great deal of new users in spaces where non-native English speaking is the norm, which has been interesting for support staff, particularly for some reason we have a fairly high load of new registrants from Brazil, so we're getting a lot of Portuguese messages. And I'm not entirely sure what drove that, and if anybody knows why, I'd love to hear about it off-site or offline, but for some reason there's a very large flux of Brazilian. Yeah? Thank you, Netflix. We've had some rise in abuse. We've had a few issues with some spammers, which we've been trying to address. And what that's mostly done for us is help us write formal policies and actions internally with the volunteers that work as admins, just to help figure out how to address them consistently. So we've actually started documenting some of our internal policies, which is a very good thing. PeeringDB 2.0, I think this has been mentioned several times in this room today. It is finally ready to launch. Woo! We are ready to cut over, and we have picked some arbitrary dates that we think are fairly reasonable for people who are integrated with it. And those dates are a cutover to PeeringDB 2.0 for the live site on August 1. And then for all of those people who are still polling the nightly SQL dump, which will no longer be a nightly SQL dump, it'll just be a static file. We'll leave it up for a month longer and watch the logs and try and contact anybody who's still using it. And then finally on September 1, go ahead and yank that file altogether. So unless there's some really nasty screaming about these dates, I think these should be pretty hard as of today. And tomorrow we're going to send out an email to the whole of the PeeringDB user space to notify them of these dates. So PeeringDB 2.0 is up now. It's up at beta.peeringdb.com. The docs are there. The APIs are live. You can log in with your existing account, browse around. You can make changes, but they'll get overwritten every night as it stands right now. So you're more than welcome to go ahead and set up your tests or get ready for your cutovers or test your APIs. You're welcome to send feedback. We've had quite a bit of feedback, and at this point, the early testers have stopped sending in bugs and have now started adding a list of feature requests, which is great. But we certainly have significant progress, and I think this is now a really good place that we can develop from. So not only does it look better and have a nice feel on a real API, but it's been developed in a way that we can actually make changes on the platform instead of this big hard cut, which is where we are now. This is a great thing for us going forward. So there's also some PeeringDB org changes. So since its inception, PeeringDB has been entirely volunteers from the community running it from everything from operational aspects like providing a place for it to be hosted and up to the people that actually run the support day to day, interact on IRC channels, take in all the emails, manage all the Ubersmith tickets, help validate that people are who they say they are. Issues like what Ren brought up, work with the IXPs to try and figure out if an IP address actually belongs to someone. And it's grown large enough and become important enough for people that have integrated with it that we need to make a few changes to the actual structure of the collective. It does need some funds for operations and software support. I mean, we certainly had about a year of development done, maybe even more than that, on PeeringDB 2.0. And those guys have all done that work for free to date. There have been a very large amount of community desires for feature requests and enhancements for PeeringDB. And while we started to catalog those, most of those were never in the plan for PeeringDB 2.0, and we certainly need to be able to provide those features and enhancement requests to the community. We've certainly had many organizations offer funds to get things done for PeeringDB, but we really haven't had a great deal of a method to receive funds and do stuff with them formally. It's had a bank account for a while, and it's been an incorporation, but nothing that would really allow us to properly manage funding these kind of projects. So we're going to put a formal process in place and manage the requests and how we spend money to do what the community would like to see done with PeeringDB. We had a lot of discussions over the last year about using an existing 501c6 as an umbrella versus launching a separate 501c6 to keep PeeringDB neutral, and took interesting feedback at AIS, NANOG, and the last GPF. And there was a strong enough feedback from the community to suggest we should launch an independent organization. So that's the path we've picked to go down. We chose a donation model rather than a member fee model for the organizational finance going forward, and drafted articles of corporations, bylaws, and the initial minutes to launch the company. And we selected an initial board for the organization, that being Chris Caputo, Patrick Gilmore, Matt Griswold, myself, and Richard Terpergen. And we will hold a community-based election sometime before August 1 of 2016, so within the next year, so those people can get swapped out or continue serving. So next steps. We've never actually sent an email to the whole of the PeeringDB community before. We've been so anti-spam, we've never even sent out a newsletter. So we're actually going to send out a single newsletter, and that's going to happen tomorrow. And that is primarily to make sure every user is aware of what's happening and allow them to sign up for opt-in lists for the pieces that they actually want to be on. There is a discuss list up now. If you want to go to lists.peeringdb.com, you can certainly get on the discuss list. But the email will go to all of you as well, as long as you have an account on PeeringDB, where you can decide which list you want to be on. You're welcome to get involved with either technical setup for, say, integration-related, governance for how the org runs, discuss for all other PeeringDB-related issues, and we're going to launch a wiki with all of the documents related to the structure of the organization as well, and that'll come out in the newsletter you'll receive tomorrow. So if you feel like donating to PeeringDB and supporting it, you're more than welcome to do so. We'd love to have it. There is a link at the bottom of the slide which will take you to the information on donation, or you can certainly send an email to sponsorship@peeringdb.com, and one of us will respond to you on the house. Obviously, we're filing paperwork in the coming week or so, but preparing for this kind of thing for budgets for years going forward is a very useful thing for all of us involved, and help us plan for the future of the organization. And that's the update for PeeringDB. So questions, comments? Rotten Tomatoes.
Curtis Lindquist, NetNode. Just a quick question. So when you send that mail tomorrow, those bounces you get, are you going to delete them from the database? And what are you going to do with the companies left with no valid entries?
That is a very good question. So we can certainly mark them as invalid in the database. I don't know that we want to delete them, but that's certainly something I'll bring up on the discuss list, and we can sort out what we do with that going forward. It's a good idea. Thanks, Curtis. Kevin.
Joe Bravo.
Oh, sorry.
In addition to the bounce processing, I'd strongly suggest for anybody who either was formerly involved or might just be demoted to guest at this point to go ahead and publish a link to it, to the newsletter on the base of PeeringDB splash page.
That's a great idea.
And I had other questions, but I'll just push them to the discuss list.
Okay. Kevin?
Kevin Bloomberg, The Wire. There are very few organizations I actually look forward to getting spam from, and I truly look forward to seeing something from you guys. So that's the first thing. It's great that this is the next evolution. You've gone from a moth to a butterfly, as far as I can see, and it's actually, we can see the butterfly about to launch.
Have you ever been called a butterfly before?
You're like a leaf in the wind, Aaron. My question for you is, I see that you're setting up an initial board to sort of guide the organization that's beginning, and that you are doing a sponsorship model. Who do you know who the members will be, so that next year, when August comes around, I have an idea sort of who the people that will be deciding the future of PeeringDB will be?
Yeah, sure. Looks like Patrick wants to jump in.
All of those are actually answered in the corporate documents, which are available as soon as you sign up for the governance list.
Outside of that, is there a simple answer?
So, we didn't want to spam literally thousands and thousands of people with all of this information. The docs are on a web page. We're going to put out a form letter tomorrow, newsletter tomorrow. We're going to say, if you're interested in the governance specifically, please join the governance list, and we'll give you access, really just a URL. Anybody can look at them. And it has things written out, such as what it takes to be a member, so that you can have a vote. We actually sat down with a lawyer to decide these things because we were afraid of going to jail. People from OpenIX scared us a little bit with their antitrust stuff. So this is all very, very well defined. And it's actually not 100% set in stone. We could change it if there is discussion and people saying that something's different. But the really quick answer is, if you have an account on PeeringDB, you get a vote.
Thank you.
Hi, Dan Golding. I think that I was one of the participants in some of the feedback you guys got. I'm a little disappointed there wasn't a little more transparency in how you went this direction, because I think a lot of the feedback you got was, in fact, that another organization might not be the best way to go, that we've already got like 8,000 organizations set up in this community. And I think there is concern over who can be a member, in particular, if you operate an exchange point, if you operate a co-location facility listed in PeeringDB. Historically, you haven't been able to become a member, whatever that means, like have an account, whatever, and you've had to put in a ticket to get stuff updated. I think there's a lot of people who have, something to gain or lose from the accuracy of the data in PeeringDB. I think this is a vital community resource, and I guess I'd urge some caution, because unless there's a lot of transparency, and unless there's a lot more listening to community involvement, it's going to be tough for folks to come up with the sponsorship money.
Absolutely. Thanks, Dan.
I think I'm next.
Red.
Thank you very much for all the effort you've put into this. It's a great start. I do wonder why there are no board of directors from outside the United States, in particular Brazil. There probably should be a voice from the market you're seeing the most recent interest. One, to better understand what you're proposing. Two, to get the word out. Three, I saw a couple of IX operators. It'd be fantastic to have one from Europe, one from Asia Pac, one from Latin America, and one from North America. Spread it out a little bit more to keep the word going.
Yep. Patrick.
So one thing that we forgot to put in the slides is I really wanted to thank Matt Griswold and his team for doing the PeeringDB 2.0 work itself. If anybody's disappointed or wondering why things aren't working the way they are, it's not like we're hiding. We come to these things all the time. We've talked to literally hundreds, if not thousands of you. And we didn't, I'm sorry, we didn't put up a spreadsheet with everything that we learned from each and every one of you. But it's not like we listened to all of you and then decided something different. PeeringDB has always done, from the day it was incepted, whatever the users wanted. And frankly, the board members were the people who showed up. We didn't go out and pick them because we thought that they were somehow wrong or different. They were the ones who put in the work, and therefore they got on the board.
Okay, last two questions at the mic, and then we'll close it.
Hi, Greg Dendy. Following up a little bit on what Dan Golding mentioned, as an IX operator myself, how can I join these mailing lists ahead of the dissemination of information?
There's list.peeringdb.com. It's got the discuss list. I'll launch the rest of the list tonight. It'll be on the same exact page.
So no membership required, no user account required?
Not to join the list, not to join the discuss list.
Okay.
Marty?
Hi, Martin Hannigan, Akamai Technologies, 20940 and 32787. Thank you very much for this work. It's sorely needed. I saw some familiar names on that board list. I trust them implicitly. In the first year of any organization, the board is typically appointed, just like this. I also think it's very important that you're all close and in the same time zones and sharing the same motives to succeed, and I'm looking forward to the elections. Thank you.
Thank you.
Right.
All right.
Thanks, Aaron.
Thank you.
Okay. So that brings us to close of the first new format peering track. Thanks to all the 6 presenters. I thought we had some great presentations, and thanks also to everyone who participated with questions and comments. We're going into break, so we have a break from 4 to 4:30. Come back at 4:30 for the closing presentations for the conference, and also remember to fill out the surveys and provide us feedback on the format changes, or come and find one of the program committee members. Thanks.